The following is a selected video from videomathteacher.com, where you can explore over 10,000 videos, print out practice worksheets, find proofs and discussions on many math topics, and explore related videos. Try videomathteacher.com today. Let's solve the system of equations 2x plus y equals 8 and x minus y equals 1. Recall to solve a system of equations that there are three methods that we can use. Our first way of solving this system will be the graphing method. That is, that we'll graph both the lines 2x plus y equals 8 and x minus y equals 1 on the same coordinate grid to the right, and then we'll determine where they intersect, which will be the ordered pair solution to our system. To graph both of our lines, we'll demonstrate graphing both these lines both by finding x and y intercepts as well as the slope-intercept method. So, for example, to graph our first line, 2x plus y equals 8, we'll graph this using the slope-intercept method. To do this, we'll solve for y. We'll subtract the 2x from both sides so that this will be in the form of a slope-intercept form of a line. In other words, y equals negative 2x plus 8. So, the y-intercept of this line is our last value, 8, and the slope, which we'll label as m, is the number in front of x being negative 2. As a fraction, this would be negative 2 over 1, which means that we'll have a rise of going down 2 and a run of going to the right 1. So, to graph this line, on our coordinate grid to the right, we'll start at the origin, 0, 0, and go to our y-intercept of 8. 1, 2, 3, 4, 5, 6, 7, 8 is this point here. With our slope, we'll use a rise and run to find a second point to draw our line. So we'll go 1, 2 units down and 1 unit to the right. Once we have 2 points, we can draw the line that passes through these 2 points. So, drawing our line, this line represents our line of our first equation, which is 2x plus y equals 8. Let's graph our second line by finding the x and the y intercepts. So, our second equation is x minus y equals 1, and to find the x-intercept, we'll let y be 0. If y equals 0, plugging this into our equation, we would get x minus 0 equals 1, which simplifies to x being 1. So our second line is crossing the x-axis at x equals 1, the x-intercept, which will be the ordered pair 1, 0. To find the y-intercept, we'll let x be 0, which means plugging in 0 in for x, we would have 0 minus y equals 1. We're simplifying that negative y equals 1. Multiplying both sides by a negative 1 will allow us to solve for y. So negative 1 times negative y will become y, and 1 times negative 1 is negative 1. Therefore, the y-intercept, where our second line is crossing the y-axis, is the ordered pair x was 0 and y is negative 1. We'll graph our second line in a different color, say blue, so that we can distinguish between the two lines. So, to graph our second line, let's plot our two intercepts. From the origin, we'll go 1 unit to the right for our x-intercept, and we'll go from the origin 1 unit down to find our y-intercept. Again, once we have 2 points, we can graph the line that passes through these two lines, these 2 points, and it will be this line that we've drawn. Note that these two lines are crossing here at this ordered pair, where we're going from the origin 3 units to the right and 2 units up. So the ordered pair solution is the ordered pair 3, 2. This is the solution to this system of equations. We can check our work by plugging in x being 3 and y being 2 into both equations, and both equations should be satisfied. So, to check our work, we'll plug in x being 3 and y being 2 into both equations. So, plugging 3 and 2 in for x and y respectively in our first equation would look like 2 times 3 plus 2 is this equal to 8? Simplifying, 2 times 3 becomes 6, plus 2, is this equal to 8? And certainly 6 plus 2 is 8. So yes, 8 equals 8 satisfies our first equation. Let's plug 3 and 2 into our second equation. So does 3 minus 2 equal 1? And certainly 3 minus 2 is 1. So since 1 is equal to 1, our second equation is satisfied. Therefore, the ordered pair solution 3, 2 is the solution to our system of equations. We found the solution first by a graphing method. Let's demonstrate the other two methods for solving a system of equations. In our second method of solving, instead of graphing, we'll solve by substitution method. To solve a system of equations using the substitution method, we'll solve one of the equations for one of the unknowns, coming up with an expression with the other unknown in it. Then we'll plug that into the other equation, which will create one equation with one unknown. We'll solve that equation for the unknown, and then plug it into our other equation to find the remaining unknown. So to begin this process, let's solve our second equation for x. So if we have x minus y is equal to 1, to solve for x, we'll add a y to both sides. This equation will become x equals 1 plus y. Next, we'll plug this into our first equation for x. This will become 2 times what x is, which is 1 plus y, plus another y is equal to 8. We now have one equation with one variable. To solve this equation, we'll distribute the 2 first, and then combine like terms. So distributing 2 to 1 and to y, 2 times 1 is 2, plus 2 times y is 2y, plus another y is equal to 8. Combining like terms, we have 2y plus 1y, which will become 3y, that we're adding to 2, that's equal to 8. To solve this equation, we'll subtract 2 from both sides, and we get that 3y is equal to 8 minus 2, which is 6. Last, we'll divide both sides by 3 so that we can isolate the variable. And we get that the 3's on the left cancel, and y is equal to 6 divided by 3 becomes 2. We now know the ordered pair solution, at least the y value, must be 2. To find x, we'll plug y into our first equation that we had solved for, and we'll be able to solve for x. So x equals 1 plus what y is, 2. And x equals 1 plus 2, or 3. And so, by the substitution method, we find the same answer, that the ordered pair is 3, 2. We have a third method of solving a system of equation, which is called the elimination method. In the elimination method, we'll add the columns of our equations together, and hopefully one of the variables will cancel out. In our case, we see that if we add 2x plus x, we get 3x. But y plus a negative y cancels out or eliminates. Is equal to 8 plus 1 becomes 9. By the elimination method, we now have one equation with one variable. So to solve for x here, we'll divide both sides by 3, and we get that, again, x must equal 3, since the 3's cancel. Now that we have one solution, we know that this ordered pair solution so far will be where x is 3, and we can plug it into either equation to solve for y. So, for example, we'll plug it into our second equation in for x to find y. We would have 3 minus y is equal to 1. To solve this equation, we'll subtract 3 from both sides to get the numbers on the same side of the equation. 3 minus 3 cancels, and we're left with negative y equals 1 minus 3 becomes negative 2. And if we multiply both sides of this equation by a negative sign, or negative 1, to eliminate the minus sign, we'll be able to find y. Negative 1 times negative 1 will cancel to become positive y. And negative 2 times negative 1 becomes positive 2. So when x equals 3, y will be 2. Again, this is the solution to our system of equations. So in conclusion, To solve our system of equations, we have three methods. We could either graph the two equations and find their point of intersection, which we found to be 3, 2. Or we could do it by the substitution method by solving one of the equations for one of the unknowns, plugging it into an equation, solving for that unknown, and then plugging it into the other equation to find the remaining unknown, which we found also to be 3, 2. Or we could do it by the elimination method by adding the columns up, and our variables would cancel so that we would have one variable in one equation. Solving this, we found x equals 3, and plugging that in, we were able to solve for the remaining variable, being y being 2, again being the ordered pair, 3, 2. So this concludes solving a system of equations with the various methods.